Good evening, everyone, and thank you for joining us for tonight's presentation, Enhancing Safety Through Autopilot Proficiency. My name is Jeff Simon. I'm president of SocialFlight. For those of you joining us for the first time, SocialFlight is the free web and mobile app dedicated to supporting general aviation. Visit socialflight.com or download the SocialFlight mobile app for Apple and Android devices, and you will have access to over 10,000 aviation events, destinations, and airport restaurants. And it's all free. You even get a weekly email with a list of all the aviation events happening in your local area. Our mission is to give pilots like yourselves more reasons to get out there and fly. Now, in addition to events that you can fly to, we also have online events, which is why we are all here this evening. One of SocialFlight's premier partners is BendixKing, and we have partnered with them, and they have partnered with TruTrak on their new Aero Cruise line of autopilots. I've been involved with Autopilot Technology for much of my career, so I am excited to have the opportunity to talk with you this evening, along with my good friend and one of the absolute experts in Autopilot Technology, Andrew Barker. Now, before we get started, here are a few tips. A recording of tonight's presentation will be available on socialflight.com within about 24 hours or so, and we will send you a link by email following the presentation once that recording is ready. And you can also feel free to post questions during this presentation. We'll have a Q&A session at the end. I'd encourage you to use the chat section. That's actually one of the easiest ways to do it. You can either post it in the question section or you can post it in the chat. The question section will only go to us as a presenter, and the chat will be seen by others here attending the webinar. So again, thank you so much for joining us, and let's get started. I will start by introducing my good friend Andrew Barker. Now, Andrew is truly, I'll be able to say this about him, he won't say it about himself, he is an icon of the autopilot industry. And, you know, you talk about a storied past, but Andrew started back when he was still in college and was the first employee at TruTrak, moved up through the ranks, became production manager, and really eventually bought out the company and became the force behind TruTrak. He became COO in 2010, and since then they became sole owners in 2014. And since that time, and in cooperation with EAA and others in the industry, they really revolutionized the way that autopilots are certified. The ability to take this new generation of autopilots and have them certified in a new way for aircraft that we all fly is something I think that's a benefit to the entire industry. And so he really is an inspiration to me in a lot of the work that I've done, and someone that we can really learn quite a bit from. And so my hat's off to you. I assume you're on the line now, Andrew?
Yes, I am here, and thank you for that. I appreciate it, Jeff.
So thanks so much. And for any of you who have met Andrew before, you understand why we have a cowboy hat and a pair of cowboy boots here instead of his face, because that's probably the most recognizable way of seeing him. And I'll turn over for a second talking about myself. We'll be sharing this presentation, and Andrew can talk about my background as well, and then I'll take you through the rest of the presentation.
Yeah, I'm so excited to be here. Thank you, Jeff. I appreciate that wonderful introduction and all the kind words that you made up about me there. I've known Jeff for several years now, actually through a couple of different scenarios, but most recently, obviously, with this venture that we're working on here on this presentation for all you fine folks. Jeff's an AMP and IA. He's an aircraft lover. He's kind of like a lot of the rest of us. He's kind of stuck in our field because we just love it so very much. He spent 20 years promoting owner assist and aircraft maintenance stuff. He writes for AOPA. He's got several FAA, FCC, and PMAs for products. We're actually discussing today how he works his PMA side into everything that he does, and it's just so incredibly cool. This is a guy who has just an absolute passion and a love for aviation and loves to share that with everybody. And I'm so honored, honestly, to be here working with him today. As he said, SocialFlight is a really great app, totally free to you, the end users. Great resource for that $100 hamburger and all sorts of great stuff like this presentation we're doing here today. And plus, this is another area where I got to know Jeff. he and his boys are building a Titan 51 in their living room, and TruTrak is honored to actually be able to work with him on that project too. So just really, really great opportunity to speak here with you, Jeff. I appreciate it.
Thanks, Andrew. So with that kind of mutual admiration society taken care of, we'll move ahead and get started with tonight's presentation. And I'd really like to start off with just some basics. So we all are speaking a common language of autopilots. And one of the most important things to understand is when we categorize autopilots across the spectrum, we think about them in terms of axes, where you're looking at a 1-axis, a 2-axis, or a 3-axis autopilot. So let's just make sure we understand what we're talking about here. So a 1-axis autopilot or a single-axis autopilot is generally only controlling the ailerons. And there's really 2 types of those that we think about. One is one that it really is just a wing leveler. It doesn't necessarily follow anything. Old Century 1 autopilots without a tracking card in them might be in this category. And then the more common single-axis autopilot is a roll autopilot. But that's when we're talking about single-axis autopilot controlling ailerons only. Then we have the next step up. That's a 2-axis autopilot. What's that adding? It's adding pitch control. Sometimes it adds trim as well, either through enunciation or through actual trim control. And remember that on certified Part 23 aircraft, the trim system is actually separate from your elevator system. That's for safety. And so you can either be enunciating about what needs to be done with trim, or you can actually control it separately. But your second axis is pitch. And then the third one is yaw damper. And it's important in aircraft like what I fly with a Bonanza. If you can do that, you get rid of any kind of tail wiggle. I mean, it gets higher performance aircraft will generally require or at least benefit from having a yaw damper. So in terms of the language, that's it. 1, 2, 3-axis autopilot. Let's talk a little bit about autopilot technology now as well. And this is important because we're really here to talk about not just how you use your autopilot for safety, but also what's happened in the industry and what's driving this new generation of autopilots that are actually out here. And this is exactly what the benefits are as we get further in and start talking about the aerocruise autopilots. So the first is the concept of rate-based versus attitude-based. Now, when we think about rate-based, think about a turn coordinator. So a turn coordinator is a rate of change instrument, and there are a number of autopilots on the market that follow that concept, that what you're looking at is you're looking for change. You're not looking for an absolute. An attitude-based autopilot would be based in the same way as an attitude indicator, where you are directly measuring through a gyroscope or through a solid state sensor. You are directly measuring what your pitch position is and what your roll position is. So you're actually seeing that directly versus inferring it through rate. So again, think of it as a turn coordinator being a rate-based autopilot. Some of the S-Techs and some of the other ones are rate-based versus attitude-based. And there's a big difference in performance between those two things. If you've ever flown through turbulence and you've watched the difference between your attitude indicator and your turn coordinator, you would see that the turn coordinator is pretty susceptible to turbulence. You see it take hits when that happens and then recover, of course. But that same thing, if that is your only measure of being able to control your autopilot, then your autopilot in a rate-based autopilot will have a little bit harder time staying stable in a situation where you're dealing with turbulence. And also, again, we're not looking at these absolutes for pitch and bank that an attitude indicator. So clearly, attitude's the way to go in terms of where technology has gone. The next thing is that technology has moved away from mechanical devices of rotating mass gyros towards solid state gyros or AHAR systems in order to measure what your position is. And that's a huge difference as well. I mean, we all learned when we went through training as a pilot about precession and other things that tend to happen that are not that really don't give you perfect measurement in a rotating mass gyro versus solid state. And in addition to that, you have the issues where, of course, if you're dealing with using your actual attitude indicator and it's vacuum powered, then you're susceptible to having your autopilot be dependent on a vacuum failure. The autopilot that happens to be in the Bonanza that I fly right now is still running off right now the attitude indicator, and I hope to change that as soon as possible. But same thing, I would lose my autopilot if I came across a vacuum failure in that. And what's interesting is in my particular aircraft, I also have a Century 1 as a backup, which happens to be a rate-based one. So I have been able to experiment myself to see by flipping a switch the difference between the stability of a rate-based versus attitude-based, and I can tell you no contest whatsoever. The difference between going to these modern autopilots is dramatic. I think the message there is there are aircraft out there that do not have autopilots. We're going to talk about why that is such a great safety add in order to add an autopilot. But even if you do have an autopilot, and it is an older autopilot, especially if it's rate-based, you really should consider what the benefits would be to your flying and to your safety by upgrading to a modern autopilot such as the Aero Cruise units. Last point on this slide, servo design. Two types of servos when we think about it. One is position, one is velocity. Now, what we're talking about there is when we command from the control unit to tell a servo to move a control surface, we're doing that in response to a deviation. So that let's say you're trying to be straight and level, and you get some turbulence and a wing gets lifted. You want to correct back for that. Well, position says that the system is designed to move a servo a certain amount, and we expect a result based on that. So it literally commands a move, and you get a result. Velocity is actually responding to what the aircraft's doing, not just what the autopilot does, but it moves it until it sees a reaction there. And Andrew, please jump in here and help me on some of these. You are the expert on some of it, but especially position versus velocity, because I know that your background with TruTrak is all about velocity on that.
You're actually doing a really great job there, honestly. I've been sitting here just nodding my head in approval with everything you've said. So the big difference for us, one of the reasons we choose to velocity drive our servos rather than position is it removes points of failure. In a position servo, you have to have a means of feedback into the autopilot. So you're going to command that position change. There needs to be either an encoder or a feedback potentiometer built into that servo to tell the autopilot that the servo actually moved where you expected it to move. In our velocity drive servo, we're commanding, again, a speed and a direction there of that servo, and we actually let the airplane close that feedback loop for us. So it gives us a more simple servo, and it also removes points of failure. In a position servo, in some, now not all, but in some position servos, you have a feedback potentiometer that can fail in that servo, leading to an uncommanded drive of the servo in either direction at what it would be equivalent to a hard over. So that's one of the reasons we remove that. Plus, we also feel that the velocity drive servo gives us a little better control of the aircraft. Also, because we use a stepper motor in our servo, velocity driving our servo is quite simple, whereas actually position driving our servo is a little more difficult with the way that we designed that stepper motor and all that good stuff in there. So that's really the main reason that we choose velocity. This is an area where I don't necessarily feel that position versus velocity, one is worse than the other. You can have a great flying autopilot with either one of those. And realistically speaking, even some of these other areas with rate versus attitude, depending on how your rate is calculated, you can still have a great flying rate-based autopilot. The issue that you do run into there with a rate-based system is if it's based off of a turn coordinator or something like that, as Jeff was saying, a turn coordinator is twice as sensitive to azimuth as it is to roll. So when you get that tail wag going in turbulence, that's when you get those uncomfortable autopilot commands that are, in a lot of times, aircraft with adverse yaw, autopilot commands are in the wrong direction initially. So that's some of the issues you can run into there on rate versus attitude. Rotating mass versus solid state. I mean, obviously you can look at the size of the electronics today versus what we had in the past. You also have rotating mass, obviously, with your vacuum pump with 2 points of failure in there. So anyway, no, you did great on covering those topics. I really like how you explained those. Great job.
You know, one of the ways that I think about it is we're at a point in technology now with avionics where obviously everything's digital. The technology has come to the point that we are able to look at things. I think of, you know, the current designs is almost like black box. If you ever did any engineering, for anyone who's attending tonight, and you look at something as like a black box solution, meaning all we care about is when we see this on the outside, we do this to react to it, as opposed to understanding and looking at every little thing. So instead of specifically going for a position, which used to be very important with older designed autopilots, now we can look at it and very quickly use a microprocessor to say, what are we getting? What do we need to do in reaction to that? And we can do that so fast that the actual aircraft control is really seamless.
Yeah, exactly.
Let's talk for a minute about,
I could not agree more.
Talk a bit about autopilot modes. So, and some of this we're going to talk a little bit more detail in a couple slides, but lateral modes, right? So we've got heading versus track. Heading, we all know, right? Heading is where the aircraft is pointed, and track is where it's actually going. And this is a really, really important point when you think about how you want to use your autopilot in addition to what an autopilot can do. Because when you think about air traffic control and the instructions that they give you, ATC has no real idea what the heading of your aircraft is. They can infer it, but what they're really going to do is look at your track across their screen and give you correcting instructions. So if they tell you to go to heading 090, you put it on 090, but the reality is you're tracking 080 because of a crosswind. Well, all they're going to do is they have to keep that in their head as an air traffic controller and now issue you 10 more degrees because they know where you actually should go. And exactly, I got a little comment from someone, give me 5 more to the left. Exactly the way that you get. And that's important because if instead you are able to fly in terms of track and control it that way, then we will absolutely be making our air traffic controllers happier, because if they ask you for 90 and you deliver 90 in track, even though they're telling you to turn heading instead of that, they won't have to give you a correction. And if a crosswind changes, if you encounter a wind shear, or if something else happens, you will continue on that track because your autopilot will correct for it. And again, you'll be making their lives a lot easier. So we'll talk about that more as we get forward, but something to consider as we go forward on this is track, much more important than heading when you're using it. Next thing is going to be GPSS, GPS steering, which is what GPSS stands for, versus GPS nav. We'll talk about GPSS in a minute, but essentially, GPS steering is actually having your aircraft follow your GPS through roll commands, exactly what it's supposed to do. GPS navigation is using a GPS course and tracking it in the same way laterally as you would a VOR course or an ILS course or any radio-based one. It's just more stable and more accurate as a source, but you are essentially still trying to follow a course deviation and keep yourself on to that. That's GPS nav. GPS steering we'll talk about in a minute, much, much, much more accurate. Those are your lateral modes, heading, track, and then you're either following a radio course, a GPS course, or the other thing we'll talk about with GPS steering. Now, vertical modes, We think if you happen to have an autopilot or have the ability of getting an autopilot that has a vertical mode, which the Aero Cruise autopilots do, well, then you have the ability to have control over your altitude. And the first way that that's done is through altitude hold. Now, some older autopilots also look at that in terms of vertical speed. When we think about what we talked about earlier with rate of change versus actual absolute, with a modern digital autopilot, you can actually say hold the altitude. Now, of course, there's altitude hold with other autopilots, older ones as well, but you're holding a specific altitude. If you're just looking at vertical speed change and trying to hold your vertical speed at 0, you can have drift. You can get bumped around. You can have turbulence that sets you off of that. And we're just trying to keep you from climbing or descending, but not holding an absolute. Altitude hold and select and pre-select, that is all part of digital autopilots and having precision around that when you do it. And again, I'm not saying that older analog autopilots do not have altitude hold. You obviously have the button for it. They do it, but they tend to not be quite as accurate as the newer ones do when they're dealing with it digitally. Lastly, we have the approach modes. Now, this is when instead of just holding an actual altitude, we are now trying to use that in command and action. And the action that we're looking to command here is to be able to fly approaches, in addition to climbs, descents, things like that. But approach modes themselves allow us to pull up either analog or GPS approaches and fly those paths. And so having that capability in an aircraft is an incredibly helpful safety item if you are flying hard IFR and you want the ability to be able to monitor all of the things happening in the aircraft, but have some assistance holding that course as you fly that approach. Again, I do see some questions coming in on number one of these, and we will get to those a little later in the presentation. Now, I talked earlier about the difference between GPS navigation, radio navigation, and GPS steering. And I'd like to talk about GPS steering for a minute because certainly in my career in avionics, it's been really, really interesting to see the evolution of this. And I think it's a kind of a good little history item for people to understand because this affects where we are today in all of our autopilots and all the avionics that we have here. Now, a GPS let me back up. When we think about a radio navigation, right, all we get out of that in reality is a course deviation. And so we can look at that course deviation, say the needle should be centered, and if the needle starts to drift right, then we want to correct left, and vice versa. We need to try to keep our needle centered. And when GPS came along, the first thing that came along with it was the idea that now we have a GPS course that we can do exactly the same thing with. We can fly it like a deviation. And the difference between that and radio navigation more than anything else is accuracy and stability. And so instead of worrying about a needle that kind of swings one way and changes based on your distance and all of this, we had a much, much more accurate path. But we're still flying it in the same way when it comes to an autopilot. We're still simply looking at it for GPS navigation and saying, are we to the right of that course in terms of a deviation? Well, we got to correct left. It's just more stable. However, the GPSs, even before WAAS came out, and absolutely when WAAS became available, became widespread, the GPSs have the ability of doing something much more powerful. There is, in digital format, there's something for the super tech. If there's any super techies on the phone right now, you can give this AirInc 429, which is a digital communication protocol, had a very specific data label in there, 121, that said out of a GPS, not here is just the course and here's how you are deviating from it, but here is the exact bank angle we need the aircraft to fly to maintain the course now and the course that we are transitioning into. And that was very, very, very powerful thing. If the GPS can output the bank angle and tell us exactly what we need to do for bank angle, well then we're on rails flying the aircraft. We just sit there and turn it exactly the bank required. A lot of these GPSs also had the ability to take in air data and even correct for crosswinds and other things, so that it was absolutely exactly what the aircraft needed to do if it could just fly this bank angle. The problem was that the autopilots at the time didn't have the ability to take that. We had the same autopilots that were originally designed to fly nothing other than a course deviation indicator, which again was swimming when it was to some degree when it was based on radio navigation, and then was solid but still trying to just react to a deviation when it was following GPS nav. Well, some very, very innovative folks found a solution that really solved things for a number of years before our latest technology now, and that was this concept of GPS steering. What they did is they took this exact output out of these very modern GPSs of bank angle, and they translated it. They actually took this digital signal and said, bank to the right 12 degrees, and they translated that into this simple voltage that went out to your autopilot and mimicked being off course. And what they did is they had you put your autopilot into heading mode, just like you were following a heading bug. So if you had an autopilot that had a heading bug, normally you would just spin it to the heading you wanted to be on, and the autopilot would follow it. So these GPS steering systems, came along and gave you this little trick that kind of gamed the system and allowed you to put your autopilot in heading mode and then switch this thing on, and they interpreted what was coming out of the GPS for roll, and they fed it a kind of counterfeit deviation out of heading, and poof, the aircraft flew it. And one of the most impressive things about that is that when we went to WAS, we actually started to get holds and anticipating turns, and your GPSs now had full courses that showed as you approached a turn a nice gentle curve, and all of those curves could be changed into bank angles, and then the aircraft could actually anticipate basically the turn and keep you on rails for the entire thing. Very, very impressive. But what it did is that technology filled that gap of translating roll out of your GPS to this analog autopilot that you used to have, or that so many of you still have. Enter now the more modern things. If you have a primary flight display, if you have a modern autopilot, as we do with the Aerocruise systems, you no longer need that because this technology is now built in. Those autopilots directly accept a roll steering command, a bank angle out of a GPS. And that's the big thing to understand here. If you are flying with an older autopilot, then it's important to understand that by switching to a modern autopilot, you cut out the middleman, even if you did invest in GPS steering. Icarus and other companies, if you've heard of those guys, really, these are the guys who kind of made that happen for a while. And now you don't see a lot of those systems sold because now it's in products like the Aerocruise directly. And so that's important. If you're looking for autopilots, understand that fully digital autopilots are going to accept that GPS steering and give you a very precision course navigation to handle that. A very modern way to follow a CDI. So that's a lot of information. Some of it you can just use for, banter at when you're getting a beer some night. But I think it's important to understand where we've come from to get to where we're going, and help you make a plan for what you want to do with investment in your own panel.
And an interesting side note there on GPS steering, actually, we actually find now that some manufacturers of other equipment that we interface with are now taking that heading command and converting it into a GPS steering type command, a commanded bank angle, directly and sending that out to the autopilot. So you actually have the opposite occurring of what used to occur, where everything was converted over to what a deviation would look like on a heading bug. Now we have a heading bug deviation being changed over to look like a bank angle command as we would normally get it out of a GPS, which is actually quite cool.
Yeah, that is really, really fascinating. And I did see a question come in from someone asking bank angle or crab angle. And that's a really good thing to clarify, because remember, crab angle is actually what the aircraft has to do in heading in order to correct and stay on the actual track that we want it to track on. But this that we're talking about now, it's an important distinction, because instead of giving you approximations, instead of giving the aircraft, giving the autopilot approximations of what it needs to do to correct for the wind, it gives it absolutes in terms of what angle does this aircraft have to be at, in what bank angle exactly. Let's not talk about it being like keep turn. The old ones used to say, turn some more, I'm still drifting. Now I'm getting a little further, turn some more. It was actually kind of like a voltage. You got more well, it was voltage. You get more voltage the further off you are. And in this case, it's not. This is exactly what you need to do to stay dead center. And that's a big, big difference.
And another point there on that, Jeff, is because you're flying a track-based system, especially with like this AeroCruise autopilot, because it is a track-based system, we don't care about what heading is. So we will fly whatever's required to keep you on course. So if the ball is centered, a la if you're not flying with your feet flat on the floor, then the wings will be level, but you would be flying with a crab basically automatically. The autopilot's going to do what it needs to do to maintain your course, and through GPS steering, that exact same thing occurs. Now, in that case, if you're on a direct path and your feet are flat on the floor and there is the equivalent of crosswind, right, then the aircraft will fly with a wing down because the ball is not centered. So to get your crab angle correct in those cases, unless you happen to have a yaw damper, you must step on the ball, just like we've always been taught, to pick that wing up, because the autopilot's going to fly the airplane just like you would with your feet flat on the floor. So if you need to maintain a course across the ground, then you got to keep the ball centered or you will have a wing down.
That makes perfect sense. Andrew, I'll hand it over to you here for trim enunciation, because I know that you are an expert more than I when it comes to trim.
Oh, you've been doing a fantastic job. So there's a couple of different ways that we can do trim. So depending on what the vertical capability requirement is of the autopilot, trim is either necessary or not. When you're talking about a basic altitude hold, like what Jeff was describing earlier, where you climb to an altitude and we push the button and we're just going to hold where we are. In that case, in these types of aircraft, the trim required doesn't change very much over even the length of a pretty long flight. Yes, you're going to burn off some fuel, so you're going to need to retrim ever so slightly, but generally speaking, very little trim would be required. When we get into the case where we actually need to have either enunciation or control of trim is when we're changing airspeeds, a la when we're changing altitudes. If we all had unlimited power, then realistically speaking, we wouldn't have to worry about retrimming the aircraft for whatever commanded climbs or descents we wanted. We would just add power to climb and remove power to descend, and the airplane would remain in trim. And then the autopilot wouldn't care about how much muscle it was using. But because we're all generally limited in our amount of horsepower, then when we command a climb, we need to retrim the aircraft for that. Not necessarily because it's going to hurt the servos or the autopilot, but because they are torque limited. They only have so much muscle they can apply. You know, if you're manually holding that climb for a long time, yeah, you're going to wear out a little bit. It's not going to wear your servo out necessarily, but it leaves us less free play for things like turbulence, which do take additional torque out of the autopilot. So it is really good to have at least a trim indication for when we're commanding those climbs and descents. Now, of course, the best case scenario is that we would have automatic pitch trim. So whatever we command in the autopilot, then it's going to automatically retrim for whatever we tell it to do in the pitch axis. Now, there's still obviously limits on that, maybe the amount we can run it or the amount of time we can run it, things like that. In the AeroCruise Autopilot, in the certified product, we don't currently offer automatic pitch trim there. We do have trim annunciation in that product, obviously, because we are commanding climbs and descents. In the X-Cruise, the experimental version of this Autopilot, we do actually offer automatic pitch trim there, with plans to add it later on down the road for the certified product. Another big reason that we do like to have that trim annunciation or trim control is so that when we take the airplane back from the Autopilot, that we have a smooth flying airplane that's not going to try to change direction on us. I do not like it when I take the airplane back and it's out of trim. Okay, slightly out of trim, no big deal, but nobody wants a 20-pound force on the controls, either left, right, or vertically. Certainly nobody likes that negative push when you disconnect the Autopilot, because it's always scary, and the passengers aren't really very happy about it. You want to go to the next slide?
Yeah, actually, let's catch up a couple quick things on the
yeah,
one before. And I just want to talk quickly because
Sure.
we talked about approach modes here. I think we missed a couple things. I want to make sure that everyone understands here the differences. So if you could cover a few things, Andrew, having to do with approach
Sure.
modes and the items on here.
Bet. You bet. So we have different kinds of approaches that autopilots can fly. You've got analog approaches, which is really the way that we're all used to flying them in the past, VOR, localizer, ILS. And then we have the new way to do it with WASP GPS, gives us a digital approach. In general, I will say that we like the digital approaches better, because now being digital autopilot, it requires less hardware, and they're actually much more precise for us to fly. When we get a digital approach out of a GPS, it basically is a fixed course width. So we don't have to worry about gains as much. You don't have to worry about things becoming oscillatory as you get closer to the ground like you do in analog type approaches. It gives us just a little bit tighter control of the aircraft. Same reason that we like GPS steering. Because of that bank angle command, it's tighter control of the aircraft, which translates to flying in the approach better. So in this specific product, again, these autopilots really are designed digital. There's actually not even an analog to digital converter in this autopilot. It is just going to take pure digital signals. Number one, it lets us build a very cost-effective product. But number two, it lets us fly all the modern approaches. We do not do the analog approaches in it, but because it is a track-based autopilot, it actually provides some capability there as well. If you know that your course to the outer marker is 183 degrees, there you go. You dial that in on the autopilot, and away we go. Same thing on commanding that descent. Once you've got the needles centered, you can engage the autopilot, and it'll actually continue to fly you on that course and on that vertical speed, keeping everything centered. Obviously, you're still watching it, but it's still a great pilot aid. So while we don't couple to the analog approaches in these types of autopilots, there are many out there that do, as well as some of the others that are offered in the experimental world, both experimental and certified world, that can fly all kinds of coupled approaches. When you get into the LPV type of approaches and the step-down approaches, obviously there's great value in an autopilot there as well. So certainly some things to look at, and we'll get into this a little bit later, but what is your mission? Are you flying IMC all the time? Are you using your aircraft for business all the time? Or are you the guy who's out just, hey, I'm going to fly an approach occasionally, maybe I'm going to stay current. I want to be able to do it if I need to let down through a layer. Those are areas where maybe flying a fully coupled approach isn't worth the additional cost required to do so. You look at the cost-benefit ratio there. Is a really important thing to look at for the type of flying that you do. Do we want to, what are we on the next? There we go. Control wheel steering. Okay. Sorry, I don't remember exactly the order we have all these in. We've changed it so many times. Control wheel steering is another really cool feature of an autopilot. It serves two main purposes. The big thing is it lets you, autopilots don't like to do things quickly. So control wheel steering lets us do a little more of that yank and bank fun flying. I use it a lot personally when I'm out just cruising around. Yeah, I may have the autopilot on, I'm sightseeing and whatnot, but maybe I want to make a 90-degree turn or something. I'm the kind of guy who's probably going to roll it to 60 degrees most of the time if I'm going to do those kinds of turns. Obviously not IMC, but this is just when we're out playing around for fun. So for me, control wheel steering is really great for that. Autopilot's engaged. Hey, I want to change to a new track, or I want to start a climb. I can just push and hold the control wheel steering button. The autopilot gives the airplane back to me, but it's ready to re-engage when I release the control wheel steering button. So upon release of that button, we're going to resynchronize to our vertical speed and our track. Whatever the aircraft is doing, it's going to keep doing. Another really
and that's really important. You know, when we think about that in terms of like getting around traffic or anything like that, you really only have two options with an autopilot that doesn't have that. You either have to break out the clutch by overpowering the autopilot if you need to in an emergency or something like that, or you have to turn it off completely and then re-engage it after you've kind of gathered yourself and get ready and get back on course, which is a lot more difficult than simply letting go of the control wheel steering button.
Yeah, absolutely. And we kind of, I'll say we kind of cheat in some of that because in the modern autopilot, they tend to not go off in random directions like we're used to, where we engage our analog autopilot of the past and the heading bug's not set exactly right. And I always forgot to set the heading bug. And so inevitably I'd turn the autopilot on and away we'd go on some 45+ degree turn. And so those are the things that we don't run into with these types of autopilots, but control wheel steering makes it even better for that. So another great feature, as Jeff was kind of touching on, is, hey, that safety aspect, I could just click the button, the autopilot's off, but maybe I want it to come back on. So I'm just going to push and hold the control wheel steering button. And then when I release, the airplane's just going to keep on doing what it's doing. So there's not going to be any surprises. If I was in GPS steering, yes, you will have to go back into GPS steering. But again, that's one button push and the airplane's not going to do anything crazy. Emergency levels, another one of those really safety enhancing features. I got to be completely honest, I was not a huge believer in this capability of an autopilot. I know that sounds crazy with the guy who sells autopilots with it in, but I didn't really find that it was a super great feature for the IFR pilot. I thought it was a VFR pilot feature, and hey, this is the great for the folks that are inadvertent IMC. Okay, I'm going to push the level button, reset, zero the airplane, let me figure out what I need to do. That is until I started talking to customers who actually have been using the system more in IMC training and stuff like that. And I've had several stories told to me where we were doing training in an aircraft and I was heads down looking at a chart and the other guy was flying the airplane and neither one of us was real sure what went wrong, but neither one of us had the airplane. Man, we just push the blue button, we go to level, we go around, and we shoot another approach. So do not be afraid to utilize your autopilot in those situations. It's a really great feature that, like I said, I did not used to believe it was a super great feature, but it has saved. I've talked to many customers that they guarantee it has saved their lives already, and we've only been offering it for just a handful of years in the TruTrak product line. So really a great feature to use both VFR and IFR pilots. The way it works in this system, push the button no matter whether the autopilot was engaged or not engaged, it's going to go to 0 bank and 0 vertical speed. Now, one area where this one's a little bit different is that it actually goes to 0 bank and 0 vertical speed, but then once the aircraft is stabilized, we actually have a timer built into the autopilot. After 10 to 12 seconds, it actually drops out of the 0 bank mode and goes back into the track select mode. So we say, okay, now we've got the airplane stabilized, give you time to get your wits about yourself. Now you want to go back into track select because you want to command a direction to get yourself out of trouble. You don't want to just command a bank angle. You don't want to sit there in the clouds in that IMC not knowing necessarily where you need to be. So it's a great opportunity for you to be able to reset, re-zero. Okay, now what direction? Look at my GPS. What direction do I need to fly to get myself out of trouble? And, sometimes that's 180 degrees, but I'll say more often than not, it's 120 or 90 degrees. So that's a reason we didn't build an automatic turn into this as well, for that same reason. AEP is a bank angle protection mode that we built into the autopilot. Man, I love this graphic. this is such a great view. Sorry, I am distracted easily. Anyway, AEP is a really great safety feature. It's where you can, as the pilot of the aircraft, you can say, all right, I want to have my bank angle protection mode turned on or not turned on. It is not on by default, and I've actually gotten a lot of questions about this at Sun and Fun this year. Primarily, I'm going to say direct result of the Boeing situations with the MAX 8. Hey, what is this mode going to do? So the difference in what you have here versus what we have in the MAX 8 is very, very significant. This is a bank angle only protection mode, first of all. So we're not commanding anything in the pitch of the aircraft. The other really important thing to note is that the pilot has the direct ability to turn this on and off at any time. It is off by default. You must engage this mode if you want it to be there. So it's only going to do something when the autopilot is not engaged in flying the aircraft. So we've got the autopilot powered up. We've got AEP mode in standby, or excuse me, in arm. And so now what we're going to do is we're going to monitor the bank angle of the aircraft. If the bank angle gets over 45 degrees of bank, we engage the roll servo at a low torque, lower than our standard autopilot commanded torque, and we command a correction back into the control system. That correction is only in there for down to 40 degrees of bank. So for that 5 degrees is when we command that. So obviously you could get above 45 degrees before it does come on, but we're going to command back to 40 degrees. And then once we get down to 40 degrees, that goes back away. We're not going to command all the way to center. And the way we actually do that is because it's a lower torque to the autopilot servo, it's really easy to fly through. So if you happen to forget that you had turned AEP mode into arm and it's monitoring the bank angle, and hey man, you know what, I really meant to be flying that 60 degrees of bank, fly right on through it. Number one, you're not going to hurt the servo, but number two, it is going to help you to recognize that your bank angle is getting high. And that's really what we put this mode in here for, was I wanted to take an active role in helping those loss of control accidents, those stall spin accidents, turns around a point, and those base to final turns and stuff like that. That's really why we wanted this mode in there, was to remind people that they were getting the bank angle higher than maybe they were thinking. They're looking at the ground, using ground as a reference. It's really easy to overbank the aircraft, and that's when those stall spin accidents occur. So that's why we have AEP in there, and kind of a little bit of how it works. Again, it's about a 70% torque to the servo. It does apply corrective action, so if you were to let go of the yoke or stick, it is going to roll the airplane level or towards level down to 40 degrees of bank, which is a much more manageable bank angle, and also happens to be a bank angle where pitch control doesn't tighten the turn. So if you're above 45 degrees and you pull, you're tightening the turn instead of getting yourself out of it. And once you're down to 40 degrees, you're helping. Autopilot integration. Sorry, Jeff, I'm running a little long on my section of time here. We're getting pretty close to the end, aren't we? Do I need to be a little more quick?
Nope. Take your time. We're good.
Okay, good deal. So
we'll hit some questions for everybody who's on the call. We'll hit some questions when we get a little further on and try to answer everybody's questions there. And so we may go long on that, but we'll have the formatting, the main part of the presentation, of course, wrapped up on time for everybody.
Okay, groovy. Yeah, we're pretty close here. No sweat. So autopilot integration. So some really neat things coming down the road there. We're actually test flying right now the final integration with two products that everyone's really interested in. We're also working on some really neat integration with these BendixKing products and the Avidyne stuff. There's some really great stuff coming out of the IFD. I've got actually a couple of Avidyne products coming here for us to do some final testing with, and we're developing a really great interface with the AeroView and XView Touch both. So really excited about what we got coming there. Biggest thing there is, in most cases, it gives us that ability to follow the heading bug so that we don't have to set it one place and then go set it somewhere else. Yes, it is a little bit antiquated still, in my opinion, that we are following a heading bug instead of a track bug. But you know what, beggars can't be choosers. And I can only hope that one day I can convince the EFIS manufacturers that a track bug is just as valuable, if not more. But I'll keep fighting that fight. Another great thing we get out of these interfaces is sometimes we get an altitude bug as well as other complex mode control of the autopilot. So we can say, all right, we're going to get altitude bug, we're going to get heading bug. We can also, in some of these cases, we can do things like altitude select directly from the PFD, as well as when you set the barometer, it pushes that over to the autopilot and all that sort of good stuff. So a lot of what these interfaces do is they allow us to interface with the autopilot through our PFD, instead of having to set something on the PFD and then go set it on the autopilot. So like you set your altimeter, it just pushes that across to the autopilot. So a lot of that neat stuff coming down the road.
And I will say, that, yeah, and I will say, integration's the key here. I mean, we all understand that there's different approaches that companies have taken to avionics integration. And we've gotten a lot of questions coming in about integration with Garmin products, et cetera. And unfortunately, a lot of those products are designed only to work with other Garmin products. But I personally am a very, very big fan of putting what I consider to be the best of breed products in my aircraft. The best ADS-B solution, the best navigation solution, the best primary flight display, the best autopilot, whatever it is that comes along, which are not always going to be all within a single family, but actually with a lot of the integration that BendixKing is now doing with products working together with other companies, kind of are under one roof. And I think it's very, very important when you think about integration to take a path and choose a product that has an open architecture, that is the corporate philosophy and the product philosophy of the product is to integrate with as many different things as possible, because that's going to leave you options for the future. That's not going to leave you beholden to a single company or a single thing, and it's going to allow you to integrate with both older products and newer products and evolve as the technology itself does. And from the back end part of it, it means that there's a whole bunch of different protocols that you don't have to necessarily know, but your avionics shop knows to understand that your next autopilot, your next primary flight display can take input from a variety of different protocols used by other products that either you already have or you may decide that you want to in the future. I'd like to switch over for a moment.
I will say ever so briefly there, to set everyone's mind at ease, yes, we are doing an interface with the G5. Yes, we are doing an interface with the Aspen. Because I know those will be a lot of the questions.
Yes, and we do have some of those. That's absolutely true. So we'll hit those questions in just a minute. Absolutely. So, the title of tonight's presentation is Enhancing Safety Through Autopilot Proficiency. And we've hit you with a lot of technology. We've hit you with a lot of understanding. I think it's very, very important to understand how these autopilots work, what the features are, how all this happens. It's also important to get some of our thoughts on why having an autopilot is so important. With this, the work that has been done to bring the cost down of adding an autopilot is, in my opinion, one of the most revolutionary things to happen in avionics and in general aviation. And it's because an autopilot can do so much for you. And it's really important to understand what a tool it can be during all of your flying, because, we talked about things like pushing a straight and level button. But one of the most important things is to keep in mind at all times, you as the pilot, as pilot in command, you have the final say about what that aircraft does. If air traffic control is issuing you commands and directions and trying to tell you to do a bunch of things, and you are behind the aircraft, even for a moment, it's your prerogative to keep that airplane straight and level, to do what you need to gather yourself. One of the most important tools I have ever used and has ever been taught to me is asking approach control for a delay vector or something that basically says, whatever's going on, I need you to send me somewhere where I can gather myself and get this aircraft and my whole plan back together. And the autopilot is one of your biggest tools in doing this. And if you, for a reasonable amount, can make an investment in an autopilot that allows you to simply put yourself on a vector, hold that aircraft level, and regather yourself in a very difficult environment, there are a few things that are as important in that. And so, very important, we've put some reasons here. FMS programming. It could be that you have to put in a complex flight plan. You need to do a readback of an IFR clearance that you've been given. You need to figure out what's going on with weather because it's closing a gap in front of you. And you need to find a better solution. You need to look out what the next, what your out is going to be in terms of like, where can I land, whether it's a fuel problem, a traffic problem, or a weather problem. And you need to look at where am I going to look that up? How am I going to talk to the flight service, or how am I going to look up the information that I need? Someone needs to be flying the aircraft during that. And the ability to do that using your autopilot, I think, is extremely important. And of course, maintaining your autopilot proficiency is a key to that. And hopefully we've given you some information tonight to help you in terms of at least understanding, and then you can go up and experiment with some of the different modes that perhaps you don't use, or evaluate them when you're looking to decide what the right autopilot is for you. But the bottom line is, you need to be flying the plane, of course. You need to be flying the autopilot, and it should never be a situation where you're wondering why the autopilot is doing something that you didn't expect it to. If that's the case, the first thing you need to do is turn it off and then figure out what's happening and become proficient in that. Andrew, you have some comments on that?
No, you're absolutely correct. And so I'm sure most of you have figured this out at this point, but this is all of these points have been collaborations between Jeff and I saying, hey, here's the areas where I think that we need to say, oh yeah, we need to add this, we need to add that. But when you need to use an autopilot, this section is, if nothing else, that if you take nothing else out of this is the area that I want you to pay the most attention to. Know when you should use your autopilot, know when it's safe to use your autopilot, and know when not to use your autopilot. And really know what your autopilot is going to do. There can be nothing scarier than being IMC and expecting your aircraft to go left and it goes right. You get disoriented so very, very quickly. So maintaining that autopilot proficiency, those two, we maybe should have put those together, but autopilot proficiency and know what it's going to do, those are really, really important points. I love technology. I am just super autopilot nerd. There's no doubt about it. But there are a whole lot of times when I would not let the autopilot fly the aircraft because I need to know exactly what's happening next. And even if I'm holding the stick or the yoke and the autopilot's in command, I feel a little bit disconnected in some of those situations. So do not be afraid to turn your autopilot off, but also don't be afraid to turn your autopilot on when it can help you.
Yep. So we're going to talk about the autopilots that are available here, a couple product things here, and then we're going to get to your questions.
So, I mean, we've kind of touched on these things. What's your mission? How are you going to fly the aircraft? Is it IFR? Is it VFR? We're showing here the KFC 230 and one of the Aero Cruise autopilots. So, you know, what's your mission? Are you flying VFR? Are you flying IFR? And even within that, what's your IFR mission again? What's your budget? What's your aircraft hull value? That's another thing to consider in this. Is it worth investing $20,000 in an autopilot for your mission? If it is, okay, that's absolutely the direction you should go. But if a $5,000 autopilot will meet your needs and your requirements, then obviously I would suggest that you're welcome to buy whichever product you wish, but buy the one that fits your budget, fits your mission, and of course the last thing is, can we even install it in the aircraft? That is another thing that we certainly need to take into account there. And so the new products here are the new products that are offered from BendixKing that we've done in partnership here with TruTrak and BendixKing. You have 3 different bezel mounting options for the 2 different autopilots. The Aero Cruise 100 is the certified autopilot. Those currently are certified for Cessna 172, 175, 177, 180, 182, and 185. also certified for the Piper PA-28 and PA-32. All of those aircraft are shipping at this point in time, although there is probably a little bit of backlog on some of them just due to them being more newly released. The X-Cruise 100 is the experimental version of this product, and it is available today for any experimental aircraft, of which nearly all popular types and kits have install kits available, and so those can be purchased through through either your BendixKing dealer or through your TruTrak dealer, either one.
So let's go and hit some questions here, and I'll go back a slide so we can have something much more attractive on the screen while we go through and hit some of these. So we've got a long list of questions. We will buzz through what we can. For those of you who have reached your limit, since we're at 9 o'clock, thank you so much for joining us. And for the rest of you, we will do our best right now to hit that. And now, a number of these we've already tackled because Andrew just answered the question. When it comes to the G500 TXI, the G500, 600, and also the G5, Andrew, I believe you said that you are working on integration for that.
Yeah, so the current products that we are working on integration with are the BendixKing product line, obviously, as well as the Aspen and the G5. We also are talking with Garmin. So in the experimental side of the G3X, obviously we have a very tight integration there. What I don't know at this point in time, and I'm still trying to get this answer from Garmin, is if you have a G3X Touch in your certified aircraft, will it still drive your AeroCruise or TruTrak Autopilot? And the answer to that is probably so, but I do not have 100% confirmation on that yet. So like I said earlier, we are in our final test flying, internal test flying right now with the G5 and Aspen integration. We've also got limited integration. I won't say limited. We have integration about to the same level with the Dynon HDX as well. And in the experimental side, we'll integrate with essentially every EFIS out there that we know of. So big thing on the certified side right now is the addition of Aspen and G5 interface. We expect that software to be finalized and submitted by mid-May.
Got it.
I can't do questions, Jeff, so you'll have to rattle them off to me.
I will fire them off to you. That's exactly why I'm here. So, first of all, differences between the TruTrak and the AeroCruise, the Vision and the AeroCruise. Can you fill us in? Are there anything there as we talk about these BendixKing products?
As of today, there's very, very limited difference. The big difference today is the bezel. But in the future, there may be some features that are added to the AeroCruise and X-Cruise that are specific to those products when coupled with the BendixKing product line. But as of today, no, they are essentially the exact same product.
Right. And I mean, that really is, when we start talking about the XView Touch and those other products, that's really the future of looking at integrating them with products like this and what kind of special features and special integration can happen between the BendixKing branded versions, I believe is certainly how I understand
That's right. Yep, exactly.
Now, there's one question about whether or not it's certified for approaches. Now, my understanding is there really isn't such a thing as certified for approaches, is there?
So the AeroCruise and TruTrak products are not FAA approved for flying a coupled approach. We actually cut off the Autopilot's approval at 700 feet currently. Now, when we were doing our approval, we asked the FAA if they wanted us to remove the ability to fly the approaches, because we weren't going to have time to do the test flying that we wanted to do to have them endorse it as approved for approach. And we were met with a resounding no, please don't remove the feature, just placard it against doing so. So it is not approved to fly couple approaches down to minimum. So you are supposed to disconnect the Autopilot at 700 feet. Yes, that is accurate. We do have plans on removing that restriction / lowering that altitude. We have been concentrating on expanding the AML so that we could be able to serve more market more quickly, and then we plan to go back and do that additional flying with the FAA to lower that altitude restriction.
Excellent. Good clarification, and definitely something I was not aware of. I knew about the 700 feet difference, but I didn't know about the certification side of it. So I'm glad we got that question. Integration with Aspen E5.
E5 will be done at the exact same time as the rest of the Aspen, the 1000 and all that sort of stuff. So yes, E5 integration is being done at the exact same time as the rest of the Aspen product.
Okay. Another question
and I will say
is it
that
possible
with Aspen, we also, that's another place where potential future roadmap can add capability to the Autopilot that is not currently there today. So we are developing a roadmap in a partnership with Aspen as well.
Excellent. Now, another question is, can you disconnect the altitude mode when you are flying an RNAV approach? Very interesting approach. So can you do that so that you have lateral guidance, but the pilot handles the vertical guidance?
We don't actually allow for disconnect of the two at this time, mostly because the way the Autopilot inner loop is written, it wants to know what's going on in both axes of the aircraft at once. And in order to fly the aircraft well, especially in pitch, you need to know what's going on in roll. But honestly, so if you are doing an RNAV approach, use the vertical speed, climb descent capability, use that as your step down, and so on and so forth. So that capability is in there. You can command the vertical speed you want there when you're on that RNAV. So it's certainly possible to do that, but we don't allow you to disconnect and fly just the roll axis or just the pitch axis in this system.
Now, can you, Andrew, can you do, aside from approaches, can you actually do vertical step downs, like whether it's part of either a Garmin product or part of the IFD, where you can put in vertical guidance on your regular flight plan? Is that something that you can fly?
So you can do that. That is a feature that is dependent upon the system we're interfacing with. Currently, now I can't promise about the future with the Avidyne and some of the things that they're working on, but I'll say that currently the Garmin product line does not output anything that is that we have flight tested yet. I've had customers ask questions about now Garmin supposedly output their step down information, and so I have not tested that, so I do not know that for sure at this point. That's something.
Yeah,
that's
and
on
that's
our
that
list
question that a customer. That's exactly the question that we got, certainly about step down altitudes there. But I also know, of course, you can put in a profile for all the different legs on an IFD as well, and it'd be interesting if your Autopilot can fly that.
And so we've been in discussion with Avidyne about that possibility. We got to do a little more digging and see what we can do to make that happen. But yes, that is a real possibility. I will say I love the Avidyne guys. I love working with them. They're super excited about, hey, how can we value add to both products by making them interface? And that's the kind of stuff that's really cool. We can add capability to both systems by working together, and we love that architecture.
How about the 770? Has that interface been done?
The
BendixKing KSN 770?
Yep. Yeah, the KSN 770 interface does work today. Through GPS steering, it can fly the approaches and whatnot. Yep, absolutely.
And now we have a series of questions having to do with individual products, individual aircraft, which I'm sure you get all the time. So let's rattle a few off. PA-24.
So let me start by saying the next aircraft we're doing is Mooney. We have Mooney in our facility right now that we're beginning design work on. Following the Mooney, our plan is the Comanches, both single and twin. And then after that, it has not yet been 100% determined what way we go. But obviously Bonanzas are near the top of the list there. also are the Grumman product line. But we have not 100% yet decided what we're doing after Comanche.
Excellent. Someone's talking about an STEC 30 with altitude hold, and to answer that question in terms of advantages, so an STEC 30, and certainly, Andrew, correct me if I'm wrong, but you're talking about, first of all, a rate-based autopilot, and second of all, that it just has altitude hold on it. And that's a separate option for anyone who happens to have that. And so when you switch to a fully digital autopilot that actually can track approaches, et cetera, you're getting stability, you're getting all the things that come with it. So pretty significant difference there versus a rate-based autopilot that doesn't actually have true vertical guidance.
Yeah, and you've also got a couple other things, and you kind of touched on it, and I have briefly as well. The autopilot knowledge to fly an aircraft well in pitch, you need to know the bank angle and things like that, because you need to be able to correct that pitch gyro and stuff like that. So to fly an aircraft well in the pitch axis, we really want to have a roll axis there, at least a knowledge of what the airplane is doing in the roll axis. And in those older analog systems, number one, they were accelerometer based instead of pitch attitude or even pitch rate gyro based. And that doesn't always give you the best capability of flying in the pitch axis. But another thing you run into there again is, like you said, that interface, there's not as much interface out to the rest of the aircraft, and the ability to control the aircraft in the roll axis, because it is that turn coordinator based system, is more limited. We also have some safety features in here, which I completely forgot until just now. Oh my God, I'm so sorry. We have things like minimum and maximum airspeed. So you can't command a climb or a descent that's going to stall or redline the aircraft. And you don't have those sorts of safety features in some of these more these older autopilot systems. And I will say that is not a unique feature to the TruTrak BendixKing product line. That is pretty much every modern autopilot, no matter who you buy it from, is going to have those additional safety features. And so I would much prefer to see someone stick within a more modern product where they're going to get better safety out of their system.
Right. And now someone else asked about, do you have to have GPSS? And the answer is GPSS is built in to these autopilots, so that intermediary system that was created years ago is now part of these modern autopilots.
That's exactly right. It's all built in. In fact, we love getting that bank angle command. There's actually an engineering mode on the autopilot that just yesterday when I was out flying, I was watching the bank angle as we were flying some of the holds, and just watching the bank angle crank up and then the autopilot just follow it beautifully is really neat to see it from an autopilot nerd standpoint. But we love that bank angle command. And when you describe the difference in GPS steering and GPS nav, you are absolutely spot on. GPS nav is a digital version of an analog CDI, essentially. It gives us cross-track air, whereas the bank angle command is just a much better way to fly the aircraft.
Yeah. Now, you talked about that you don't really deal with analog signals. So does that mean that you actually, the autopilot actually cannot fly a true ILS or VOR approach?
So that's correct. In these specific products, we are not able to fly an analog coupled approach. Now, I will say I can't always speak for what the future holds in both products from me and products from someone else that might create synthesized versions of those types of approaches and output them digitally to the autopilot. That's another place where you can talk about value added in partnerships. So, there are some really distinct possibilities of giving this autopilot, even a simple autopilot like the Aerocruise and X-Cruise, more capability when it's coupled with some of these more modern other systems in the aircraft. Right.
Now we're coming up against a hard stop, so we're not obviously going to be able to answer tons and tons of questions and get through everything. Hopefully we have gotten through just about everything that we have here. But the most important thing is that you can always follow up from tonight's presentation and be able to reach everyone that's here with more information. Andrew, would you like to give some contact information for yourself and for the AeroCruise products?
Yeah, absolutely. You can always find information. First thing is check out the BendixKing website or the TruTrak website, either one. And those are going to be great knowledge bases to do additional research. Or obviously through Jeff on a lot of his stuff, there's a lot of great resources there as well. But you can always give us a call here at TruTrak. If you've got a question you want to ask us directly, you can call us on the phone. It's 479-751-0250. Like I said, or visit us on the website, TruTrakAP.com. You can send in questions and contact information there as well.
Yeah, I think that, obviously the most important thing is, we're talking about a new family, a new line of products with AeroCruise, with AeroView, with the other touch products from BendixKing, and the partnership with companies such as TruTrak. And so BendixKing.com, best source for all of that. There are also contact information directly on there. Certainly I'm happy to help, but most of the questions I can really answer about SocialFlight. So the best solution following this is to actually reach out directly to BendixKing at their website, to their technical experts there. And if there's anything that they need additional help on, then of course Andrew is working very, very closely with them on that next generation line of products. And so for SocialFlight and also for BendixKing, I'd just like to thank everyone for taking time out of their evening. Hopefully you came away with a couple pieces of information that you didn't have going into it. And we would just like to, again, thank you so much for your time. Please do check out SocialFlight.com. We have many more webinars coming up, including more from BendixKing, and a lot of other really fascinating things coming on. And more than anything, we want to get you all out there and flying. So we'll give you a new mission, a new destination, new things to do. And also, we have something called the Fly to Win Challenge in SocialFlight. And that actually lets you fly to airports, fly to events, get points. And there's a drawing happening on a regular basis for great prizes, which include avionics gifts from BendixKing. Prizes that you can win worth thousands of dollars from BendixKing that will be part of the Fly to Win Challenge. So you can see that directly for SocialFlight, and of course, everything is free. So again, I'm Jeff Simon from SocialFlight. Thank you so much for coming this evening. Have a wonderful evening.